Welcome back. Today we are going to solve a problem related to simple harmonic motion, and the question reads: a body of mass 20 kilograms performs a simple harmonic motion at a frequency of 5 over pi hertz. At a distance of 56 centimeters from the mean position, its velocity is 420 centimeters per second. Calculate its question 1, maximum displacement from the mean position. Question 2, the maximum velocity. Question 3, the maximum acceleration. Question 4, the maximum potential energy. And question 5, the period of oscillation. So what we understand from this is we have a body that is performing simple harmonic motion, and the mass is 20 kilograms. The frequency is given as 5 over pi hertz. We are given the velocity as 420 centimeters per second when its displacement is 56 centimeters. Okay, so we have a displacement of 56 centimeters when the body is at a velocity of 420 centimeters per second. So we'll move on to answer the questions. We have velocity as 420 centimeters per second. So we have to convert it to meters per second. So it is already in per second. So which means it's only the centimeters that we have to convert to meters. So if you have 420 and you divide it by 100, that will convert it to meters per second. So if you have 420 centimeters per second, you want to convert it to meters per second, just divide by 100, you will get the answer. The displacement is 56 centimeters, so we have to convert it to meters by dividing it by 100. That will give you 0.56 meters. So the first question is the maximum displacement from the mean position. The maximum displacement is also called the amplitude. Okay, so basically we are asked or questioned to find the amplitude. So using the data that I have above, the mass, the velocity, the frequency, I should be able to use them to find the amplitude. Okay, but before doing that, let me try to find the angular frequency. And the formula for angular frequency, omega, is equal to 2 pi f, because it is very important for me to be able to get the answers. So that is going to be 2 times pi times what is the frequency. Frequency is given as 5 over pi. If I have that, pi will cancel. Then I will have 2 times 5. And 2 times 5 will be 10. And angular frequency is measured in radians per second. Okay. So I know that v, that is the velocity at a given point, is equal to omega, the square root of a squared minus x squared. Okay, You can also see it in other textbooks as v squared is equal to omega squared into a squared minus x squared. It's all the same, because if you take this square and send it to the other side as the square root, you will have this. Okay, so to make the work simpler, I'm just moving on with the first formula. All right. Okay, so what was the velocity at a given displacement? Velocity was 4.2. So I can substitute what is v is 4.2. 4.2 is equals to the angular frequency is 10, the square root of a, the amplitude, that is what we are finding, to amplitude squared, minus the displacement there is 0.56, so it will be 0.56 squared. Okay, so what can I do? I can divide both sides by 10, both sides by 10. That will be 0.42 is equal to the square root of a squared minus what is 0.56 squared. That is 0.3136. Okay, so what can I do? If you have the square root and you want to cancel it, then what you do is you introduce square. Okay, so if I should square both sides, square these sides and square these sides, then square and square root will cancel each other. So what am I going to have? 0.42 squared is 0.1764. This is equal to a squared minus 0.3136. So what do? I can collect like terms. I can send 0.3136 to the left side of the equation. That will be 0.1764 plus 0.3136 is equal to a squared. So what does that give me if I add 0.1764 plus 0.3136? That will be 0.49 is equal to a squared. So if a squared is equal to 0.49, I want to find a, that is the amplitude. So that is going to be the square root of 0.49. And the amplitude is, what is the square root of 0.49 is 0.7. So it will be 0.7 meters. Or if I want to express it in centimeters, I will multiply it by 100, and that will give me 70 centimeters. Okay, so it means the amplitude is 70 centimeters or 0.7 meters. That is question 1. Question 2 asks us to calculate the maximum velocity. So where is the maximum velocity attained? If you watch our previous video, we said that if at all you have a displacement and energy graph, energy is measured in joules, we have the kinetic energy like this, and we have the potential energy curve like this. Okay, so this is the potential energy. Let me try to differentiate them with a different color. I will not spend much time to explain this, so you can watch our previous videos. Okay, kinetic energy is the curve that I represent with white. Okay, and that is the potential energy U. The potential energy U. We say the maximum kinetic energy. This is called this point is the mean point or the equilibrium point. Okay, the mean point. Okay, this is going to be the amplitude. This is going to be the amplitude on the other side. Okay, so the maximum displacement or the maximum horizontal displacement, it is what we call the amplitude. Okay, and so we said that if you are moving from the amplitude towards the mean position or the mean point, what happens to the kinetic energy? The kinetic energy increases. Okay, you can analyze it like this. From the amplitude towards the mean point, if I should follow the curve, what happens? The energy, kinetic energy increases. Okay, but what happens from the amplitude towards the mean point? What happens to potential energy? The potential energy decreases. Okay, so here we are asked to find the maximum velocity. So where is the maximum velocity attained? The maximum velocity is attained at the mean point. So sometimes they may ask questions like this or ask you to draw this energy displacement curve. Okay, this point is where maximum velocity is attained, and it is at the amplitude where maximum acceleration is attained. Okay, velocity, maximum velocity is attained at the mean or the equilibrium point, but maximum acceleration is attained at the amplitude. Okay, so kinetic energy is also maximum. Kinetic energy is also maximum at the mean or the equilibrium point. Okay, so potential energy is maximum at the amplitude. So it's good for both your objective and some theory questions. All right, moving on. We want to find the maximum velocity. And the formula for maximum velocity is Vmax is equals to omega A. Okay, is the angular frequency multiplied by the amplitude that will give you the maximum velocity. So what is the angular frequency? Is 10 multiplied by the amplitude. Amplitude is 0.7. 10 multiplied by 0.7, so that is 7 meters per second. The maximum velocity is 7 meters per second. Question 3 asks us the maximum acceleration. The maximum acceleration is given by the formula minus omega squared amplitude. Okay, so the maximum acceleration will be negative. What is the angular frequency? It will be 10, so 10 squared multiplied by the amplitude is 0.7, so that will be 70 meters per second squared. Okay, so the negative sign is only there to indicate that acceleration and the displacement are in opposite direction. Okay, so that is the acceleration, and acceleration is maximum at the amplitude. Okay, it's maximum at the amplitude. Moving on, question 4 asks us to find the maximum potential energy. Okay, so energies in simple harmonic motion are frequent questions, so it's important you know all of them. Okay, so the maximum potential energy is given as half m omega squared a squared. Okay, so this will be half. The mass is given as 20 kilograms. 20 kilograms. So that will be 20 multiplied by the angular frequency is 10. So it will be 10 squared multiplied by what is the amplitude. The amplitude is 0.7. So that will be 0.7 squared. And what do you have? Half so if you punch all that, you will have 490 joules as the maximum potential energy. We are not asked to find the maximum kinetic energy or the total energy, but I just want to spend some time to go over them quickly. Okay, kinetic energy at a point, if you ask kinetic energy at a displacement, if they give you displacement or at a point, is given as kinetic energy is half m omega squared into a squared minus x squared. Okay, so but kinetic energy that is maximum, that is maximum kinetic energy, is given as k max is equals to half m omega squared a squared. Okay, so potential energy at a displacement, when they give you the displacement, u is equals to half m omega squared x squared. That's the formula. But maximum potential energy u max is equal to half m omega squared a squared. So if you look at it, maximum potential energy and maximum kinetic energy are the same. Okay, they are the same. So the last thing is called the total energy. How do you find the total energy? The total energy E is equal to half m omega squared a squared. Note that. Okay, that is also the same as the maximum kinetic energy and the maximum potential energies. Okay, just to remind you. All right, so we will continue to solve other questions. All right, so that's question 4. Question 5 ask us to find the period. Period is what? Giving us 1 all over the frequency, or the period is 2 pi all over the angular frequency. These are the two formulas that you can use to find the period. So period is equal to 1 divided by what is the frequency. The frequency is 5 over pi. So if I have that, that is the same as saying 1 divided by 5 over pi, right? So to change it from division to multiplication, I will invert. Okay, so that will be 1 multiplied by pi over 5. So therefore period is pi over 5. If you want to leave your answers in pi, that is how it is going to be. But if at all you want to substitute the values, what is pi? Pi is given as 22 over 7. So it will be 22 over 7 divided by 5. Pi equals to 22 over 7 times 1 over 5. Pi is equal to 22 all over 35, and that will be 0.63 seconds. Okay, we can also use the angular frequency. So period will be 2 pi all over what is the angular frequency is 10. So period will be, if 2 goes once here, here is 5 times, you'll have pi over 5. You see the same thing. So that will bring you to this. Okay, and you can have it as 0.63 seconds. Okay.